look at how scenes work in CATIA, how we can build them within an assembly, and how we can apply them in drawings as well. Learning what the difference in a full scene is and a partial scene and exploding components and that kind of stuff. So that's what we're going to focus on. Let me go ahead and get into a little bit of this. We're going to jump back and forth between lecture and demonstration, showing you the differences between the two, and then I'll show you a bunch of different demonstrations here at the end. But if you're not familiar with what a scene does in general, basically, scenes allow us to display a snapshot of assembly within a user-defined state. Basically allows for a configuration of components. So when you're dealing with assemblies, especially large assemblies, we may want to deal with different configurations, different layouts of those components without having to build multiple files. So let's say we want to have one assembly where it's fully assembled, one assembly where it's fully exploded. Those are common applications for scenes. But it may also be a situation where you're dealing with a large assembly and you want to build and work on components that are internal to that assembly. And you have to sit there and hide a bunch of parts that are there. Well, if you're doing this multiple times, and you got to go back and re-hide all those components every single time you want to work inside that assembly, it would be easier to create what we call a scene to be able to automatically toggle between parts being displayed and parts being hidden. Or maybe you want to move the parts off to the side. Maybe you want to show it in different states of assembly so that you can show how it goes together. The first three parts are assembled. You take a snapshot or a scene of that. Then you show the next 3 or 4 parts being added to it. And by creating these different stages that you can quickly toggle to whenever you need to, you have one master assembly file that will control all those different layouts or looks of that assembly. So scenes allow us to customize specific component attributes. There's basically 4 main values that we can customize about our part scene. We can customize their positions, so where they're at. You move them up or down, left or right, or back and forward. We can customize their graphical attributes, basically their color. So if you don't want the standard gray, you can make them blue, green, red, yellow. Maybe you want to highlight all of the fasteners, or you want to highlight a certain surface, you can make those colors change. Node activation, so whether the parts are activated or deactivated, so whether it speeds up our process of working with those components, and hiding and showing, so just making a part visible or not visible. So those are the only real things that a scene is controlling, is those 4 settings. It may not control all of them at one time, but it has the ability to control those 4 settings. So benefits of scenes: save various view settings in a one product model. So we can have an exploded and a fully assembled look all within one model. We don't have to have 2 separate assemblies to control that. And if you modified one, you got to remember to go back and modify the other. With scenes, it's all in one location. We can quickly switch between our scenes whenever we need to. And it's all saved in the product file. So if you're building scenes in the normal assembly or product file that you're dealing with, you'll see a category at the bottom called applications. If you expand applications, scenes will be listed there, and then whatever scenes you've created will be listed underneath that, whether it's a partial scene or a full scene, and whatever names you happen to give it. Okay, so benefits of scenes. Scenes can be used to view and simulate the progression of an assembly that's being created. I mentioned that earlier. Here we show a couple parts being arranged in space. Now we've added a couple more, and then we've added a couple more. We can have 3 different scenes, and through a series of right clicks or applying the scene, we can get it to display either one of these 3 configurations at any given moment. Okay? In our print, we can call on which one of these we want to see as well. And again, we're only linking to one assembly file instead of 3 separate assembly files that have different parts. That's a general introduction to what scenes do. To be able to record those settings, we're going to overload the properties. Okay? Overload properties is just Dassault's way of saying record that value. So when you're building a scene, there is a button in your assembly workbench. It's also found in the DMU workbench if you're familiar with mock-up tools. But either one allows you to get to the same button here called Enhance Scene. When you select on Enhance Scene, it's going to bring up this dialog box, giving you this ability to either automatically name the scene or name it ourselves. Now, if you leave automatic naming turned on, it's just going to call it Scene 1. The next one will be Scene 2, Scene 3, however many you build. And all it tells us is which one you built first, second, and third. They don't have any other context to work off of. So we highly recommend that you turn off automatic naming convention and you create your own names. Give it a little bit of meaning. That way, if you see it a month from now or if somebody else sees it, they're going to have a general idea of why you built that scene based on the name that you gave it. We also recommend that you create what's called a default scene or an all parts scene. The default scene is just a safety net so that if things ever go crazy on you and don't go the way you want them to, never happens ever for anybody, right? But if things don't go the way you want them to, you can always fall back to everything being back to its fully assembled state. Okay, so we do want to make sure we make a default scene. Depending on whether you use partial or whether you use full, it does require different steps. Now, what does this partial and full really mean? Okay, well, remember I said there's 4 settings that can be recorded about a part. Well, if we use partial, it's not going to record those 4 settings unless we tell it to. So if I've got an assembly of 10 parts, 4 settings for each part, I have the potential of 40 different settings to be recorded. But when I start off with partial, none of those 40 settings are recorded. I have to manually tell it, hide this or show this or overload a setting, which is either position, color, hide, show, whatever. Remember, overload just means record. Record that setting, and now that list, instead of having 40 things recorded, it might have 5 things recorded. It might have 10 things recorded. So it's a partial list of all 40 things that might be there. A full overload mode here is going to record all 40 settings for the 10 parts. And again, 10 parts, 4 settings for each. That's where I'm getting my 40 from. So when I use partial, it starts off with nothing recorded and it allows you to decide what is being recorded and what isn't. When you choose full, it's going to record all the settings right away. If you change them, it will change those recording, those modifications. Maybe you hide a part or you show a part or you move a part around. It'll record those as well, but all 40 items are recorded. The idea is 10 minutes later, when you say, you know what, I want to apply that scene. I want the parts to move into position. If the list only has 10 things on it, that's the only 10 things it can reference. The other 30 things that were there are ignored because it didn't record them in the first place. With full mode, it recorded all 40 settings, so all 40 of them are going to be applied and moved into position. Now, I know it's all theoretical right now. I'll show you what I mean here in just a moment. Okay? So that's generally what the partial and full does for us. So with full, all components in the assembly are overloaded. They're automatically recorded. New components are not added to the scene. That's the only kind of downside to the full mode, is that if you create a scene with 10 parts, it records 40 settings, and then you add an 11th part, that's 4 more settings that are not recorded. And so when I apply that full scene, that part isn't affected, isn't even shown in the scene. A partial scene, if you add a part later after it was built, that 11th part, it won't have any settings recorded for it, but it will automatically display in the partial scene. And I'll show you examples of each one of those here in a moment. Okay. So what do scene overload modifications do? Scene overload modifications make the overload properties independent of the original CATIA product. So these settings are independent of the original assembly. These properties extend to the children and selected component of in addition to the selected product in case the overload property option. So if you choose a subassembly, it automatically applies to all the parts that are inside that subassembly if you overload those settings. Now, the options to be able to overload them, there's 2 different ways of doing it. You can manually just right click on something and say hide show. That will cause it to record the hide show status. Or you can click this button here, which records its current status. If it's currently visible, it's going to record it being shown. If it's currently invisible and you select on it in the tree and hit record, it's going to record that it's currently hidden. We can record the position, so where it's at on the screen. We can record the graphical attributes, again, the color it is currently, or the overload mode node activation, so whether it's activated or deactivated. Okay, when you're building your scene, this enhanced scenes toolbar will appear. And right here, if you hit the flyout, you'll be able to see those 4 buttons and choose to record those settings if you wish. Okay. In fact, this only shows up for partial scenes. Remember, partial scenes do not record anything by default, so now we're telling it to record those settings. If you're using a full scene, this is all grayed out because it's automatically recording all these settings. It's not going to ask you to hit record. It's doing it for you. So let me do a little bit more here, and I'll do a demonstration. So where can I find and build my scene? Well, depending on which workbench you're using you may find the enhanced scene button in different locations. If you're working in the assembly workbench, which is what I'm going to focus on, you'll find your enhanced scenes toolbar. There's the enhanced scene button, and we've got a few other buttons there as well that we'll talk about. And then if you're using the DMU navigator workbench, the digital mockup navigator, which has some functions for being able to view assemblies, you will also have the ability to create scenes. Now, they will be found on different toolbars, but the same functions exist in the DMU workbench as they do in the assembly workbench. Now, to build your scenes, we're going to use enhanced scene, which is right here or right here. Once selected, again, you turn off automatic naming, and I'm going to suggest, highly suggest, you automatically create either one called default or all parts, or you can give it whatever name you want. But this is a fallback. Really, we're not going to customize too much about it. We're going to leave it exactly the way that it is. Now, we can choose either partial or full for this one. There's an argument to be made for either one, and I'll show you the pros and cons of them. But once you build your scene, you hit OK to that, you'll get this staging area. The staging area is kind of a green background. It's also a good reason not to make your CATIA screen ever that green color, because it's trying to show you you're in a different environment. This is your practice area. This is where you're able to play with it and line things up and record what transitions you want, whether you want the movement changed, the color changed, hide, show, activate, and deactivate. This is where you're able to perform it. You're not actually changing the assembly yet. You're just changing the scene. Okay? I like to think of it like a football team. And this is the practice time. We're able to tell our players to move all into position where we want them to be. When it's game time, we'll just call our play, we'll apply the scene, and all of our parts will move into position. It's just a matter of calling the play we want, and all the parts move into position. You can follow that silly analogy. Now, when you're in this green background, you will see a new toolbar here called Enhanced Scenes, and it gives us some tools for recording, for exploding our scene, and there's an exit button here. If you hit the exit workbench icon, it will boot you out of that scene and take you back to the workbench you came from, which in my case will be the assembly workbench or the DMU workbench. And you're done modifying that scene. If you want to get back into that scene, you just double click on it, and it will take you back to this green background and allow you to modify the scene that you have and get back to your practice area so you can call your play. Now, when you're dealing with a partial scene again, you will have the ability to record different attributes. So I can record whether it's activated or deactivated, or whether it's hidden or shown. We can change its color. We can save viewpoint, so where the camera is specifically looking at it from a different orientation, so it'll move into that orientation for us. And we can do explodes, which move the parts away from one another. We can see them in alignment. Once a scene has been created, okay, remember we created in that green background area. We're not really changing the assembly, we're just changing the scene. However, if we want our actual assembly to look like that scene, we will right click on the scene itself, go to whatever the name of it is object, apply scene on assembly. So it's going to take on all those positions, all those things that were recorded, and you'll say apply entire scene. So that list that I was mentioning, those 40 things, if it was a full scene, all 40 of them are going to be applied to that model. And the models are going to move in the right position. It's 10 of my settings. They're going to all be visible or invisible. That's 10 of my settings. It's going to be activated or deactivated. That's 10 of my settings. And it's going to change their colors. So there's the other 10. If you ever forget what those 4 things are that scenes are supposed to be remembering for you, they're right here. I can apply just the position. There's just 10 of the settings. Hide, show, graphical, that's color, and activate and deactivate. So those are the things that it's trying to remember for us. And instead of applying all 40 of them, even though the list says 40 things, I could apply just 10 of them at a time if I need to. So let me show you a quick demonstration of this, and then I'll come back to some more of this presentation. I've got this turbine here, and we can see it consists of a bunch of different parts. And I want to be able to create a couple of scenes, one being fully assembled and one being fully exploded, so just separated from one another. To do that, I'm going to first find my scenes toolbar, okay, normally found in the lower right-hand side of CATIA inside the assembly workbench. So you see the two little gears up here in the upper right-hand corner. I'm going to click on the Enhance Scenes command, and I'll call this one Default. Now, I'm going to start this by making it a full scene. The default is going to be fully assembled, everything in position, exactly what you see here. Sometimes referred to as all parts. You can call it whatever you like, but I'm going to hit OK, and it takes me to this staging area, this green background. Sometimes you'll actually get a little pop-up that says modifications made to this scene can affect the assembly. Are you sure you want to do this? Hit OK to that. That's expected. And what you'll be able to do here is basically we're going to change nothing. Okay, we're going to hit exit scene, and it's going to stay exactly the way that it was. Remember, a full scene records all 4 settings for every single part. So I don't know, there's 10 parts here. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 8 parts. So 8 times 4, we're looking at 30 whatever parts. That is our list that's been recorded. And with that list, if I ever make changes to this and I move my parts around, in fact, I'll come in here, grab this, and just playing with the assembly, I start manipulating things. If I want it to go back the way it was, I can go back to default, right click on it, go to whatever the name of this object, apply scene on assembly, apply entire scene. And all those positions move back. Now, it wasn't just positions, it was color. They're all still gray. I didn't change those. They're all still visible. I didn't change whether they're hidden. But if I hide a part, if I come in here and take this part and change its color, right click properties, go in and make it teal color, whatever I want to do, if I need to go back to the default, I have it to be able to apply entire scene, and it goes right back to that configuration. Now, I want to do something where I can actually customize this and remember to go back to it later. So I'm going to build an exploded scene. I'm going to click on the Enhance Scene button again, turn off automatic naming, and I'll call it Exploded. Now again, there's an argument to make it as partial or full. I'm going to make this one full. And notice they both come in as red axis systems over here in that tree. Those red axis systems mean that they are full scenes. Okay, if I now use the Enhanced Scenes toolbar that appeared, I'm going to click on Explode. And Explode gives us a couple of different functions. Well, ultimately we're exploding it, but we can say just explode the first level. That means that the top level assemblies will explode, but the secondary assemblies will not. So if there's any sub-assemblies, they'll stay together. This one doesn't have any, yes it does. It does have one sub-assembly, but there's very few and it's not going to do too much for us. I can say explode all levels of the assembly will explode. We can also tell it what's exploding. That's the top level assembly. You could just pick a sub-assembly and watch that fall apart while the rest of it stays together. And then type, 3D, 2D, or constraint-based. If I go with 3D, all of them are going to explode in the X, the Y, and the Z direction. If I go with 2D, it will explode up and down and left and right, but not backwards and forwards. And if I go with constraint-based, it's going to try to use the constraints that I have, sometimes with varying success, to be able to explode this and keep aligned with main axes or main surfaces. Excuse me one moment. Sorry, I did not want to cough into the mic. So I'll hit apply here. Actually, there's one other option. Do a fixed component. If you want one component to not move, you can choose it. So maybe I choose that one. Now when I hit apply, we see all the parts move away from one another. Take a drink. Maybe that will help with my cough. So it shows the explosion that's here. And even though I used constraint-based, it didn't quite explode the way I would have rather it exploded, where everything lined up on one another. I could cancel that, go back to explode. Let's go with a all levels 3D explosion, using what's fixed. And we can adjust it and play with it. Or you can manually explode it, which means you use your own compass and drag them out where they need to be. If you grab the slider, here we can drag it back together and we can pull it back apart. And it also depends on how it was constrained, on how well that constraint-based explosion works. Now I'm gonna hit OK. And I've customized this the way that I want right now. If I hit exit scene, it now shows me the fully assembled assembly again. I haven't actually changed the assembly in how it looks. All I've done is created another play in my playbook to be able to call on, and that will make the assembly change. So for example, if I come over here to explode, right click, go to whatever the name of his object, apply scene on assembly, apply entire scene. Now the assembly takes on that look. It now shows us with a fully assembled or fully exploded look up to our parts. Now, if I go back to default, apply scene on assembly, excuse me, that puts everything back together. We have those two options. Okay, so that's generally how we build a scene. I'll come back and talk about the difference between partial scenes and full scenes here in a moment. I come back here to my slides. Modifying a scene. So after you build it, how do we make modifications to it? Well, there's a couple of options. One, you can just simply double click on the scene in the tree. So as long as you expand down far enough, you can double click on it and the green background will show back up. Or you can select on the scene, right click, right mouse button on it, choose whatever the name of it is, object, and then choose definition. I would much rather double click on it, but you can do that as well. Or you can activate the scene by going to the scenes browser. If you go to the scenes toolbar right next to enhanced scene we're just showing you, if we click on this button, it will show us a list of all the scenes that have been created. Now, you can choose what you want to have happen when you double click on these. If you come down here to customize, customize will allow me to activate the scene, which makes it look like it is, makes it automatically apply it. We can have it apply the enhanced scene to the assembly. So it's not just going to turn green, but it's going to make the assembly to move into that position. Or we can apply the user-defined attributes. When you double click on one of these in the list, it'll automatically apply it to your assembly. Okay, so it's just a way of being able to, if the names were terrible, here we didn't rename them. So there was scene 1, scene 2, and scene 3. I don't know the differences between them. I can kind of view them here before I double click on them to get them to apply the actual screen. Another option we have is to be able to manually apply them through the dashboard here. So we can tell it what's being recorded and what isn't. To do this, you'll be able to right click on the scene, go to whatever the name of it is object, and go to set user defined attributes. This will create this dialog box and allowing us to be able to record whether the position's being recorded, hide, show, graphical, or activation. It also allows us to see what has already been recorded. So if these are my 10 parts, here's 10 of the settings, here's 10 of the settings, here's 10 of them, and it adds up to the 40 that I've been beating into you so far. Okay, so far we only recorded hide, show, so only 10 of the settings were recorded. Exploded scenes, I kind of got into this already, but we have the ability to be able to either manually explode or use the explode command to be able to show them in different configurations. Again, selecting explode will bring up the dialog box. We'll be able to define depth at all levels or at the first level. We'll be able to define them whether it's 3D, 2D, or constraint based. Now here's what I was actually looking for in the assembly. If I had lined up all of my curved surfaces here to be coincident to the next curved surface and line up with the main axis, you'll see it explode in a more traditional way than what you're seeing in my demonstration. But I'll also show you how, even if it does kind of fall apart on you, you can use your compass to help you get it exactly the way you'd want If we go with a 3D explosion, it moves up, down, left and right, and forward and backward as it explodes. If you go with 2D explosion, based on how you're looking at the screen, it moves up and down and left and right, but will not move farther away from us or closer to us as they separate. And again, once you apply the explosion, you can grab the slider and move it around. If there is a subassembly, the subassembly will assemble first as you move the slider to the left. Once the subassembly is assembled completely, then the main assembly will move together. Okay, and if you've got 3 levels of assemblies or 4 levels of assemblies, the smallest assemblies will assemble first before the large level assemblies move together. Now, once a scene is created, it's nice to be able to flip through these configurations within CATIA or within DMU or whatever viewer you're looking at. But how does this help us in manufacturing it? Not everybody's going to, not everybody, few people are going to actually have computer terminals right next to your machines to be able to manufacture these parts and be able to look it up and see all the different configurations that are there or how it's being assembled. But usually we have prints to be able to use, and we want to be able to take that scene and apply it to the print. Well, generally it's the same process for building any other view. The first thing you do is you create your drawing file. You're going to generate either a front view or an isometric view. Either one will work. So here we're going to create a front view. Where then, once we choose the front view, we go back to the assembly. We select on the scene, and then we're able to place it on our drawing. So it's the only real difference. Actually, you select on the scene, you select on the part or a view, and be able to place it. So here's an example. If I want to create the front view, I select the front view icon. I'll be able to go back to the assembly. I click on the scene itself, and then I click on the surface or the plane that I want to represent the front view. Okay, that's going to give you your camera orientation. Now, when we go to place it into our print, it's showing us a preview of it. It will bring it in, but it comes in already exploded where the parts are separated from one another. Okay, we can do the same thing with an isometric view. So let me show a little bit more here, and then I'll talk about tips and tricks. So I've got fully assembled and fully exploded. If I want to create a print of both of those different views, what I'm going to do is go to File, New, choose Drawing from the list, choose whatever my standard is going to be. We'll go with something a little bit bigger. And with the files I currently have open, I have 2 assemblies and 1 drawing. I'm going to be able to select on either front view or isometric view. Either one will work. And the way you bring them in should be the same. I'm going to click on isometric view, then toggle over to the compressor that I was building. And I'm going to select on the default. Well, first, I'm just going to select on the compressor. So I just click somewhere on it. I'm not using a scene here, and it brings it in just like it looks inside the assembly. Okay, and I'll put that there. Now I'm going to do it again. Click on isometric view, go back to that compressor. This time I'm going to click on default first, then I'm going to click on it from this current vantage point where my camera is looking at it from. They look identical. They're not. And I'll show you in just a moment here why they're not identical with one another. Do it one more time. This time, instead of selecting on default, I'm going to select on explode. Choose the part from that vantage point, and I see it comes in from the same viewing point, the same angle my camera is looking at it, but they're all separated from one another. Now the first one, remember I selected on just from the assembly. Here I selected on the scene first, then I selected on it in the assembly and got a different look to it. If I go back to that assembly and I made a change, and I'm going to take my compass, put it on this part here, pull it out, and turn it 180 degrees just to look at it differently. If I hit update, well, sorry. If I hit update, the constraints pull it back, so I don't want to do that. If I have it moved there, then go back to the drawing, I hit update on the drawing, which is what I went to do. Notice this one changed. It's always showing us exactly what the assembly is supposed to look like. These two have not. They're recorded based on what was recorded in the scene, which the positions were all in together here. The positions were all moved apart in this orientation. Okay, so that gives you an idea of how we can use these scenes within a drawing. Now, one other thing that I want to talk about, which I kind of skipped a little bit in my lecture, is the partial scenes. Okay, basically the partial scenes are not going to record unless I tell them to record. So to build a partial scene, what I'm going to do is I'm going to select on enhance scene. I'm going to leave it on partial, and I'll call it partial filter. And hit OK. You can call it whatever you like. One thing you'll notice is it has a black axis system to it instead of a red axis system. Now, again, if there's 10 parts here, 8 parts or whatever, all those parts for the full scenes, 4 settings recorded for each one. With the partial filter, right now, nothing has been recorded. That list is completely empty. However, if I take one part, right click on it and go to properties, and I say that color is going to be yellow now, it is recorded the color change of that one part. If I take another part and I move it back here, and I flip it 180 degrees just so we can see it do something different, it has recorded that change. So my list, instead of being 40 long, is just 2 long. 1 color change, 1 position change. And I'll grab one other component, and I'm going to hide it. So 3 things are in that list. When I exit my scene, it's as if nothing has happened. Again, that was my staging area. That was my practice area. If I apply that scene right now, it'll do exactly what you just saw. This will turn yellow. This will flip around 180 degrees and move back, and that one will hide. It doesn't really show you what the intent of a partial scene is. Instead, I'm going to apply the exploded scene. Remember the exploded scene, all the parts are moved into different positions. They're all gray, they're all visible, they're all activated. And if I now apply the partial scene, I'll apply all the settings. Only 3 things change. Okay, because the list didn't have the position of this part or the position of that part or the position of that part. Those didn't change, but it did have the color of what this part should be, so that was able to change. It did have the position of where this part should be, so it moved. And it hid one of the parts because it didn't care where it was located, but it knew it should be hidden. An example is I work with a customer that makes large trucks. And with these large trucks, they may have a fully assembled truck and a fully exploded truck. And we want both of those to be displayed. However, in both those cases, they have these big side panels that are just pieces of sheet metal that cover up everything. So whether I have it fully exploded or fully assembled, those side panels are going to cover up my front view, my side view, my top view, and just cover up all the working components of that truck that I might want to see. So what I might create is a partial scene where I hide all the side panels. Now, whether it's fully assembled or whether it's fully exploded, I can apply the partial scene where the side panels are hidden, and it shows me the truck still fully assembled or still fully exploded with the side panels missing. Or I can change their colors that way. Maybe I want to be able to highlight all the electrical components. Maybe I want to highlight all the purchase parts. Maybe I want to highlight the problem parts. I can have a partial scene that applies them, whether it's fully assembled or whether it's fully exploded. Okay, now here's one other difference between partial scene and full scene. If I was to go to insert existing component, choose my assembly, and I go find some part. So I'm going to place this spider bearing, which is another example I have here, but I brought that in. Okay, it has been brought in after those 3 scenes exist. If I was to apply the default scene, it shows all the parts move back into position, but that part is not moving. If I went to the partial scene, apply the entire scene. Again, it's ignoring that part completely in the assembly because there's no positions ever recorded for that, no colors ever recorded. It's just sitting where it's at. Okay, that might seem reasonable right now. If I double click on default, in the scene itself, it acts like that doesn't even exist. So if I wanted it to exist in this scene, I would have to delete the default and create a new one. Okay, if I exit that scene, if I go to explode, it didn't exist with a full scene, so it wasn't there when I go to modify it. However, the partial scene, it does exist. I can record it. I mentioned earlier, there's an argument to be able to make your default scene as partial or full. What you may want to do, and I'm actually gonna make everything go back the way it was, apply scene on assembly, is I'm gonna delete that default scene. Instead of trying to modify it, I'm gonna create a new one. I'll call it default. I made sure to get everything back in their original position before I did this. And I'm gonna make it partial. Now, if I make a partial scene and do nothing to it, there's nothing recorded. Basically, the list is empty. So anytime I try to apply that scene, it's going to look at the list and say, there's nothing here. So whatever you have must be fine, because it's not different than an empty list. So what I need to do is record what I want recorded about this default scene. So what I'm going to record is I'm going to record the positions of all the parts. I'll select the top part, hold shift, select the bottom part, and record its position. Now the list has been populated with those 10 things or 9 things. I'm going to select all those parts again, and I'm going to select whether they're hidden or shown, which they're all shown. It's recording that. I'm not physically having to change them back and forth from hide to show. I'm just telling it record its current value. I'm going to tell it to record its overload graphic. And I'm going to tell it to record its activate and deactivate. Do you have to record every single one? Not necessarily, but it doesn't hurt either. When I exit this, now the default is a partial scene, but I've recorded every single attribute that could be recorded. So it's kind of like a full scene. However, when I add more parts to it, it will automatically display them, which it wasn't before. So now I can come in here and apply this partial scene. Those parts move around, change their color and hide. I can apply the full scene, which again only affects the parts that existed in it. If I double click on it, remember it doesn't show that part that was added in afterwards. But if I take this one and apply the entire scene, they all move into position in their default locations. Okay, for example, one more time here, I'm going to turn or make a test partial. This time, I'm not going to record anything. I'm just going to exit it. So that list is empty. Well, if I try to apply the partial scene right now, apply entire scene, it says there's no difference between the scene and the main assembly because the list is empty. If I went and applied it as fully exploded, and then went to partial and said apply, again, the list is empty, so there's no difference between them. Okay. Let's see, come back in here. Some tips and tricks. Suggested scene techniques. Once a scene has been applied, users cannot undo those changes. Therefore, creating a scene with no configurations before creating a scene like an all-part scene is recommended. The user-defined all-part scene can be used to restore the original assembly configurations. So they're calling it all parts. I called it default. You can call it whatever you like, but by recording all the parts in their fully assembled position is going to be a safety net, if not anything else, to make sure everything goes right back the way it was. Okay. If you have lots of sub-assemblies, and there's constraints throughout all of them, depending on the type of constraints there are, you might think that just hitting update will bring them all back together. That doesn't always work. especially if you use fixed together constraint in there. If you separate them, it'll be fixed together in a separate position. And then when you try to hit update, it becomes more problematic. Creating a default or all parts seen is going to save you some time and frustration. Old scenes, if you want to be able to update an old scene, you can either double click on it and make changes to it, okay? Or like you saw me doing a little bit ago when a part was added, I may apply that old scene, then delete it, and then recreate the scene using the current positions that everything is in. Okay, I've kind of done some of these demonstrations. Let me do just a little bit more here with this spider assembly, and then we'll see if there's any other questions that might come up. But I'm going to close this one. It's taking longer than I expected. There we go. We'll go to this part, and we have currently the part sitting there fully assembled, or assembly, I should say, with all the components. What I'm going to do is click on Enhance Scenes. I'll leave a partial scene, but I'll call it all parts this time. Now you need to record what's being done to all of these components. So I'm going to select on every component here, and I'll be able to say record positions. I wish it remembered my selections. There I would say hide shows recorded, record their overload graphics, and overload activation. Again, by overload, they're just saying record those values. When I exit this, that isn't any different than what you're seeing here. But now I can start getting creative. Now, with how I want to get creative on this, I'm going to come in here with Enhance Scene. We'll just call this Explode. I'll make it a partial scene. And when I go to explode it, I'll be able to choose what's stationary. This orange part's going to be stationary while all the different bearings are going to slide out. I'll be able to hit apply. And we see them all separate from one another. Okay, I'm going to exit that scene. And we see the assembly hasn't changed. Okay, if I want to create a partial scene where only certain components are, let's see, small explode. I will come in here and select the subassembly that I want to explode for us. Click the explode function. I'm going to have none of them be fixed. That starts to separate. Now, it did some of what I wanted, but I actually wanted pulled out away from it as well. What I can do is grab that subassembly, use my compass, like you would when you're originally assembling an assembly, and I can move this around as well. So maybe I want that one pulled apart. Maybe I want to grab this one over here and pull it out, but not have it be exploded any more than that. And the other ones are just going to be fit into position. It recorded just what I modified. Now I can apply the exploded scene. All the parts move away from one another. I can apply the all parts scene, they all move back together. Or I could come in here and apply just the small explode. These parts move into their new position, which wasn't that far from that original. And this one moves back together, while those have not changed. I can apply all the parts together and separate them. Also, if you want to be able to make a recording of where things are at, one thing you can do is right-click on your partial scene. This only shows up as partial scenes. Go to whatever the name of it is object, and there's Manage Attributes Overload. Here's a list of what was recorded. So some of these parts did not have anything recorded from position. Some of them did. If I want to record its position, I want to record its graphical attributes, instead of having to manually right-click on it, or instead of having to choose record position or record color, the little buttons that are there, I can do them from here. So for this part, I want to record all of those settings. All 4 of the settings recorded for just that part alone, whatever that part happens to be. Some bearing that's there. Okay. Now, if you're interested in more information on scenes, we cover this information and more about assemblies and controlling different looks and drawings within our Advanced Assembly Design and Management class or our DMU Navigator and Space Analysis class. Those classes are traditionally 2 days material. They go through all kinds of different things, but this is just part of the material.